Hi guys, welcome to this page notes, and you're probably thinking to yourself, hang on a second, we're going backwards, we already did this. I know. To get to the next page of the notes, right, I just want to sort of give you a real simple idea here. What's going to happen is we're going to take both of the special right triangles we just talked about, and we're going to go ahead and make the value of x in each of these ratios a 1. So what happens if x is equal to 1? Well, if x is equal to 1, the length of this side would just be 1. And the length of this side would just be 1. And the length of this side would be the square root of 2 times 1, which would be just the square root of 2. Same thing over here. If I go ahead and make x equal to 1, then the length of that side would be 1. The length of this side would be 2 times 1, which would just be 2. And then the length of this side would be the square root of 3 times 1, which would just be the square root of 3. So that's what's going to happen here on the page of the notes we're about to go to. All I've done, the 45, 45, 90, the 30, 60, 90, where we've made the value of x 1. And the ratio that shows up is 1 to 1 to square root of 2. 1 to 1 to square root of 2. And 1 to 2 to square root of 3 to square root of 3. Okay, that's where those ratios come from. So here we go. This is going to be the page of the notes that most of you probably flipped to. And now you see why I went back, right? 30, 60, 90. What is the ratio of the lengths of the sides? 1 to 2 to square root of 3. This is the 45, 45, 90. The ratio for the lengths of the sides, 1 to 1 to square root of 2. Now, why? Why does that matter? Well, here's what we're going to do. Go ahead and look at it. We're going to write the trig ratios, sine, cosine, and tangent. Here's where they show up, sine, cosine, and tangent, for both of these special right triangles. Okay, here we go. I'm going to need some space. Let's go ahead and divide these guys right here. Then I'm going to do for the, let's do for the 30-degree angle, and then let's do for the 60-degree angle, right? Because I got two different acute angles over here. And then in this guy, right, I'll write just one, right? 45 and 45, both, since the angle measure is the same, the trig ratios will come out to be the same. So we only have to do it once over here, 45 degrees, right? Whatever the sine of 45 degrees is here will also be whatever the sine of 45 degrees is over here, right? Because sine of 45 equals sine of 45. There's no reason to do it twice because they're both the exact same angle. That's why I got to do it twice over here. Different angle, 60 degrees, 30 degrees. Anyway, here we go. All right, let's do sine. So we're going to do sine of 30 degrees is equal to, well, here's, right there, there's my 30 degrees. There it is right there, 30 degrees. Remember, sine is opposite over hypotenuse. Opposite, hypotenuse. 1/2. Perfect. Okay, cosine. Cosine. 30 degrees. Well, there's 30 degrees. Cosine is the adjacent over the hypotenuse. 30 degrees. Adjacent. Hypotenuse. Square root of 3 over 2. Fantastic. Tangent. The tangent of 30 degrees. Remember, tangent is opposite over adjacent. Okay, here we go. There's 30 degrees. Opposite. There's adjacent. 1 over the square root of 3. Ooh, problem. Remember, we cannot leave radicals in the denominator. No hiding radicals in the basement without proper permitting, and you don't have the permits. So we're going to need to go ahead and get that radical out of the bottom. We saw this on the previous page. You'll simply multiply top and bottom using a process known as rationalizing the denominator. From Algebra 1, rationalizing the denominator, multiply the top and bottom by whatever the denominator is. So, square root of 3 times the square root of 3. And what that leaves me with is square root of 3 times the square root of 3 is just a 3. 1 times the square root of 3, that's square root of 3. So we get square root of 3 over 3. Rationalizing the denominator. I'm going to go ahead and erase this and slide this guy over so I'm not running into my stuff over here. Erase, 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 erase. And again, what we wound up with was square root of 3 over 3. Awesome. Now 60. All right. Sine of 60. Okay, well, again, here's my 60-degree angle. Sine is the opposite over the hypotenuse. Opposite, hypotenuse, square root of 3 over 2. Is that okay? Absolutely it's okay. The radical is in the numerator, which is where I want it to be. We got to bring those radicals out of the basement. Don't hide radicals in the basement. He's not in the basement, right? He's sitting upstairs in the living room, so we're good. He's fine. Cosine. Cosine of 60 degrees. Well, here's my 60-degree angle. Cosine is the adjacent over the hypotenuse. Adjacent, hypotenuse, 1/2. There should be no surprise here. We saw this when we were talking about the sine and the cosine function, right? I have these two acute angles, right? Whatever the sine is of 30, that's going to be the cosine of 60, right? Remember, they flip-flop when you switch acute angles. Sine was 1/2 when it was 30, so cosine will be 1/2 when we go to the 60-degree angle. Since cosine of 30 was square root of 3 over 2, guess what sine will be? Right, square root of 3 over 2 when we flip-flop angles, right? Those guys just interchange places. And then do you remember what happened to the tangent function? Tangent of 60 degrees. Well, there it is right there. There's 60. Tangent is the opposite over adjacent. Square root of 3 over 1. Well, square root of 3 over 1 is just going to be the square root of 3. Square root of 3. So there we go. Our three trig functions, sine, cosine, and tangent, for both of these acute angles of 30, 60, 90 are right. We're writing the ratio. Writing the ratio for each of these trig functions based on an acute angle and the ratio that we know for the special right triangle 30, 60, 90. All right, let's do it for this guy. So we're going to have sine of 45 degrees. Sine is, again, it doesn't matter. They're both exactly the same, so it doesn't matter which one you pick. Here's 45. Sine is opposite over hypotenuse. Opposite, 1 over hypotenuse. That's 1 over the square root of 2. That is no bueno. Multiply top and bottom to get the square root of 2 out. And we wind up with square root of 2 over 2. Okay, cosine. Cosine of 45 degrees. Once again, 45 degrees. Cosine is going to be the adjacent over the hypotenuse. What? I wind up with the exact same thing. 1 over the square root of 2. Cosine's no different. That radical cannot stay in the basement. We got to bring him up. Rationalize the denominator. And yes, absolutely, this is not a mistake. The ratio, the 45, 45, 90-degree triangle, another reason why this one is special, both the sine and the cosine have the exact same ratio, square root of 2 over 2. They're equal. They're the same. So yet another reason why this guy's kind of special. And then tangent. Tangent of 45 degrees is equal to, again, tangent is opposite over adjacent, so opposite over adjacent, 1 over 1 is just 1. So the tangent of 45 is 1. Now, what you'll see in most textbooks, even though we can go ahead and find them ourselves, most textbooks will go ahead and give you those values in a chart, something like this. So for the 45-degree angle, sine, square root of 2 over 2, cosine, square root of 2 over 2, that's what we just found up there. Tangent was equal to 1, there it is, that was tangent. For the 30 and 60-degree angles, right, they'll go through and give you the values for the sine, cosine, and tangent. Again, though, we just found those values up there by simply setting up the ratios that we learned about tangent, sine, and cosine, basing them on our two special right triangles, the 45, 45, 90, and the 30, 60, 90. All right, head on over to the next page of the notes. We'll talk about a really important topic known as the Pythagorean triple. I'll meet you there.